Hello everybody, this is a little video for an illustration of how to use the extended Euclid algorithm from the example in the course. So you have here the little table with the line number from 0 to 6. It's used with A equal to 30 and B equal to 7, and you also have the main formula to create a new line. LK is equal to L k minus 2 minus qk times L k minus 1. So if you remember, actually, this algorithm is designed in two steps. The first one is initializing the first two lines with actually in the RK column the values of A and B. So here 30 and 7. Then initialize UK and VK as most of the time actually the U coefficient is associated to A, so this appears as a 1 here and a 0 there. And on the next line, actually, VK is kind of associated to the value of B. So once this is done, actually, the step is to compute the Euclidean division between RK and RK plus 1, that is 30 divided by 7, so that we get the quotient. Actually 30 is 4 times 7 plus 2, so we have the value of Q2 equal to 4. So it's not, now we use the general formula so that we can compute L2 from K2, L0, and L1. So U2 is equal to U0 minus 4 times U1. It's 1 minus time for 0, which is 0, so it's still a 1. Then same thing for V. V2 is 0 minus 4 times 1, which is minus 4. Then for same thing for the R column, it's 30 minus 4 times 7, and actually we should find the remainder of the division. As RK is not equal to 0, then we go on and use line 1 and 2 to compute line 3. So 7 divided by 2, the quotient is 3, and the remainder is 1. So now we have the value of Q3, which is 3, and we use exactly the same technique so that now U3 is 0 minus 3 times 1, which is minus 3, and V3 is 1 minus 3 times minus 4. So here be careful to the fact that the minus sign in the general formula is not written in the QK cell here. So you have to be careful to the fact that actually it's 1 minus 3 times minus 4. So minus 3 times minus 4 is plus 12. Then it's 1 plus 12, which is 13. Same thing for R. 7 minus 3 times 2 is 7 minus 6 is 1. Once again, we find in the RK column the value of the remainder of the Euclidean division we've done just before. So RK is not equal to 0, so let's go for here the last step. Actually, it's 2 divided by 1. The quotient is 2. The remainder is 0. So Q4 is equal to 2. Let's go for the last calculation. Then it's 1 minus 2 times minus 3, which is plus 6. So it's 7. Minus 4 minus 2 times 30. 2 times 13 is 26, so it's minus 26 minus 4 is minus 30, and then 2 minus 2 times 1 is 0. So when the remainder is equal to 0, the algorithm is over, and we know that we've got the results we want on the line which is just above the one where a 0 appears in the RK column. So you've got the results here in line number 3, stating that, U is equal to minus 3, V is equal to 13, and you also have the value here, the GCD of 30 and 7 is equal to the value which is located in the RK column is equal to 1. So 30 and 7 are relatively prime numbers. So now we can do a quick check about the fact that the thing is okay. So actually, as this algorithm is used to find the coefficient for Bezout's identity, those coefficients should fit. So this means that minus 3 times 30 plus 13 times 7 should be equal to the GCD that we found, which is 1. So we can check that quickly. Minus 3 times 30 is minus 90. Actually, 13 times 7 is 91, which is actually equal to 1. That's a quick way to check that the calculation is correct. So in the next video, I will take an example with other values.